There we go. And let me go through sharing my screen. All right, cool. Is everybody seeing screen looking good? People seeing what I'm seeing? Awesome. Okay. All right. So what, oh, oops, wrong thing. That was all the answers to your problem set. Close that out. Well, I'll edit that out of the video. All right. So just as a recap for where we left off last time, we had a question where we want to look at some interactive effects of PTSD, pain, and opiate use on role functioning. This is the same set we've been using over and over again. So we're just running some moderation analyses. The same ones that we walked through in class, just doing it in SPSS. Okay. So first thing we did is we first went through and computed centered variables. Chris M., can you tell me why we computed centered variables?
The centered variables make it easier to compare across just like this study in general, or it, like if they're skewed for some reason, it makes it easier to interpret.
Yeah, it's interpretive things, right? And so when I center a variable, what's the mean of that variable?
It is 0.
It's 0. Does the standard deviation change?
No, the standard deviation doesn't change, and the distribution doesn't change at all.
Yeah, it just makes 0 the mean, right? And why is that helpful for interpretation and regression?
Because if there are, I think it's if there are measures that might not otherwise, like, say if you have like a 1 to 5 Likert scale, that might not actually have like interpretable value,
right?
Or something. So
right.
if you transfer it to centered variable, it's much easier to interpret.
Yeah, on the right track. The idea is that, remember, any effect in a regression model corresponds to the unique effect of that variable on our outcome, holding everything else constant at 0. And by mean centering, what this does, if we hold everything else constant to 0, that means we're holding everything held constant at the mean. And the mean is a nice sort of interpretable value versus if I'm, say, as Chris Emmett noted, if I'm looking at weight, right? A mass of 0 is not a real mass of somebody to have, right? Or height of equal to 0, things along these lines. And so instead of interpreting our regression coefficients as the unique effect of x on y, when everything else is literally held at 0, we're still holding it at 0. It's just now 0 corresponds to the mean value. Okay, so we went through and we calculated centered variables, and then here it's just looking at our regression models with and without centering, and so you can kind of take a look at that. But then we went through and computed interaction terms, and in SPSS, this is how we need to go through and build these interaction terms, literally creating an interaction, an actual variable. So we're computing a pain times PTSD and an opiate times pain. These are our two interactions, right? And so tomorrow, can you tell me what these terms are testing? My interaction terms.
And like in a regression model?
Yeah.
They're testing whether the effects of opioid use are affected by pain ratings.
Yep. And what about this one?
Whether pain ratings are affected by PTSD
ratings. Right. So this is a test of our conditional effects, right? These are our moderation effects, right? This allows us to see whether or not we have evidence for conditional effects in this of pain and PTSD, and in this one in pain and opiate use. Now, Nick, does it matter which one? I mean, are we forced into a position in terms of these interactions, which effect is our conditional effect and which is our moderator?
No, they're mathematically interchangeable.
Mathematically interchangeable, and so it does not matter this is going to be based primarily on your theoretical model, right? And generally what this is going to involve is saying, all right, what do we have lots of evidence for? We have lots of evidence for a relation between pain and functioning, right? That's not interesting. But what we might be interested here is whether or not opiate use changes the nature of that relation, right? We know that PTSD is related to poor levels of functioning. Does pain severity impact that, right? But we could easily flip it around and look at it either way, okay? Now, sometimes what we find, and if we look here, here's the results of our, here's our coefficient table for our interaction model, right? And we see, we'll call these interpretable interactions of PTSD and pain and opiate use and pain for the purposes of our demonstration, right? And so, for example, so we got an interaction of PTSD and pain, right? And we see that we have a conditional effect of PTSD here with a p-value of 0.012, right? So it makes sense to say, so it's pretty easy to say, does level of pain change the nature of this association here, okay? But what if, and so we've talked about the conditional effect of pain on functioning across people who use and don't use opiates. Could we talk about the conditional effect of opiate use for people high and low levels of pain? Chris C., could we do that?
We talk about opiate use for high and low levels of pain?
Yeah.
Yeah, sure.
Yeah, we could, right? We could. But looking at this, what might be kind of tricky in terms of talking about the conditional effect of opiate use on functioning at high and low levels of pain? What's our p-value for opiate use?
It's right on
No, just our conditional effect of opiate use.
Oh, conditional effect. It doesn't seem like we have a lot of evidence that's making a difference.
Yeah, right. And so this is where conceptually it starts to maybe get a little bit tricky when you're talking about, if you have a strong a priori hypothesis, it's easy, because then you're just going to say, I'm looking at the conditional effect of X on Y, or of my predictor on outcome at high and low levels of whatever my moderator is. But sometimes we don't have strong hypotheses going into this. And so in this case, it might be hard. It's just maybe a little bit less direct argument for how pain moderates the unique effect of opiate use on functioning. Because based on this model, does it look like opiate use has a unique effect of unique association with functioning?
Not really.
Not really, right? Now, if we were to look at this at high and low levels of pain, what we might find is that it does hold an effect somewhere. So I'm going to try something new here. What we might see, all right, is we might have an effect, that looks something like, right? And this is functioning, right? And what we might find is that opiate use and functioning has something that doesn't look very strong, okay? But if we look at this at high and low levels of pain, at high levels of pain, we might see something like this, and at low levels of pain, we see something like this, right? And so it's important to recognize that what could happen, I guess, and Nick, if you're looking at this graph here, what is the effect? What is the conditional effect of opiate use on functioning here?
The conditional effect was just that there doesn't really look to be an effect, but it differs at high and low levels, so that's kind of interesting.
Yeah, right. So we could say at average levels of pain, which is what this is looking at, right? Because we centered everything. So this is the conditional effect of opiate use on functioning at average levels of pain, okay? But what we might find is at average levels of pain, Opiate use doesn't hold an association, right? But at high levels, you got a strong positive relation. At low levels, you got a low positive relation. And so this is also why thinking about and considering moderation effects can start to become important, because if we just looked at the average effect of opiate use on if this is actually what was going on, and we just looked at the relation of opiate use with functioning at average levels of pain, Nick, what would we conclude?
There's no relationship.
There's no relation. When in fact there is a very clear relation. It's just that relation is conditioned on pain levels, right? What type of error would we have? What type of violation of our assumption would result in us missing what might be a very important association between opiate use and pain, or opiate use and functioning? Yeah, CJ?
2.
What's up?
Type 2.
Okay, yeah. It would be a type 2 error. What problem do we have in this model if we don't model the interaction? Anybody remember that's called?
Omitted variable bias.
Yeah, or a misspecification error, right? Omitted variable bias is a form of misspecification error. Basically, we don't have the right model, right? We're missing an effect that's important in there, right? So just something to think about as we're going through and doing this. So with this effect, the way it is, it's probably going to be easier to talk about a conditional effect of pain on functioning for people with and without opiate use, because holding opiate use and holding pain or PTSD constant at the mean and controlling for opiate use, we still have a conditional effect of pain here, right? So we can talk about, does opiate use strengthen or weaken that association? Might be a little bit more tricky to talk about whether or not what the conditional effect of opiate use on functioning looks like at high and low levels of pain, because what this could also look like is it might also look like something like this, where at one level it's this, and another level it's like this, but I might find that neither one of those simple slopes we don't have strong evidence that either of those simple slopes are different than 0. And so what it ends up is kind of a weird, kind of ambiguous effect. We know that pain does change the impact or the relation of opiate use and functioning. It's just the way we've modeled it. It's kind of a mess, because we can't really say anything, versus if we were to look at pain and functioning at no opiate use and opiate use, then we get a much clearer picture here. Okay. Does that make some sense to people? People kind of see how we're thinking about this a little bit. So mathematically, they're interchangeable. Conceptually, you may have sort of stronger idea that one may be a better approach than the other, but you might have to play around with this a little bit. Okay. So went through, ran this analysis, and Ignacio, what did we find in this coefficient table? I think you're on mute. Oh, there we go.
Before your question, I have a question.
Yes.
May I ask first?
Yeah.
You're saying we will have a misspecification error if we don't consider the interaction term.
Mm-hmm.
Where pain will be seen, you can tell is somehow influencing.
Mm-hmm.
But what about if we just didn't come up with the interaction term because we thought that the literature is not telling you to run the interaction?
Yeah. And this is the thing. This is the problem with misspecification errors. We have to know about our area, about the data, about the phenomena of interest to try and make sure that we're including. Now, there are some techniques to go through and explore model specification. I was working with one of my students with this sort of earlier, but then the problem you run into with that is picking up on nuances of an individual data set instead of something that's sort of an actual real effect. And so it's a tricky thing, and it's hard to go through and make sure that we 100% always have a properly specified model. But this is where it is incumbent on researchers to make sure that they're thinking about this carefully and making sure that you've got, based on the literature that's available, there's always a possibility that you've omitted something, right, Sean? There's no way to 100% say, oh, this is the perfect model and there's nothing in there that doesn't need to be in there and nothing that's in there doesn't need to be, right? This is a conceptual exercise. Okay, so with our coefficient table, what do we find when we ran that overall model, Ignacio?
We have the coefficients. Well, considering that the variables, the predictors are centered.
Uh-huh.
All the unstandardized coefficients that will tell you if you increase in 1 unit one of the predictors, the outcome will move in the same magnitude as stated by the coefficient in the unstandardized column.
Sure.
If you move one standard deviation, the predictor, you will move the outcome in that magnitude of the standard deviation as stated by the column of standardized coefficients.
Perfect.
The t-test and the significance.
Right. And so for our interaction terms, what are we seeing here?
Both of them are statistically significant. The last one is in the threshold. So it's your call if you want to call it.
Yeah. Probably what I would do is we're going to move forward and investigate both of these, but you'll see kind of what's going on with this. I would say we have fairly strong evidence for interaction of pain and PTSD, right? And we might have some weak level of evidence for an interaction of pain and opiate use, but we'll go through and take a look at that, right? So we went through, and what we can do is we can go down through and then by hand, and I'll ask you to do this, create a simple slopes analysis, right? And this is where we're just going through and factoring out our model. We're just taking our coefficients here, our constant coefficient for pain, opiate use, PTSD, and our interaction terms, using those to create our regression model here. And then we're just going to go through the factoring that we did in class. And what we can do is we can go through and we can create and hand calculate my simple slopes for role functioning, PTSD and role functioning at low pain, and PTSD and role functioning at high pain. Okay, and we can do this. Oh, I didn't mean to do that. We can do this all by hand, right? And this is pretty slick. We can go through and plot this out. But CJ, we can do all this by hand based on our overall model. What doesn't this tell us?
You mean this graph here?
Yeah.
It doesn't tell us whether each slope itself meets benchmarks for statistical significance.
Yeah, right. We don't know if either one of these slopes are non-zero, right? Looks like this one probably is, but this one, I don't know. Looks like the actual coefficient here is positive, suggesting that for at low level or at high levels of pain, every unit increase in PTSD is associated with a 0.04 unit increase in functioning, right? That's weird. I don't expect PTSD to be associated, increasing PTSD to be associated with increasing functioning. So I might want to know, is this noise or is this something that's actually telling me that there's a positive association there, right? So in order to test this, this is where we went down through and started changing the centering of our moderator to test specifically whether or not we have evidence for an effect at high and low levels of pain. So here we created a recentered, or not centered, but a rescaled variable for low pain, rescaled variable for high pain. For low pain, we added a standard deviation. For high pain, we subtracted a standard deviation. A little counterintuitive, but we're just moving that 0 point around. Then we went through and we computed new interaction terms. Any interaction term that had pain in it, we now created a new interaction term substituting low pain for pain. and then create a new set of interactions substituting high pain for pain here, right? And then what we did is we ran two separate regression models. We ran a regression model looking for the simple slope of PTSD on role functioning at low pain, and the simple slope of PTSD, testing the simple slope of PTSD with role functioning at high levels of pain. Okay, and this is where we've got those, right? And Chris M, what for both of these models, what's the only coefficient we're interested in these high and low pain models? Oh, you're muted.
Yep. The interaction between pain and PTSD.
Okay. Well, the interaction, remember that the interaction term is going to be the same, right? So if we look at our low pain model, our high pain model, our interactions are the same thing here, and that's good. Our higher order terms are always going to be identical, right? But what are we most interested in? Why are we running these high and low models in the first place?
Because we're interested in whether there is or is not a non-zero effect of these interactions.
Of the simple slopes, right? And so what's the simple slope of interest here? The association of
between pain and PTSD.
Okay. Well, the simple slope is going to be the association of PTSD and what's my outcome?
Functioning, sorry.
PTSD and functioning, right? So when I go down through here and I take a look, the only slopes that I'm interested in is going to be the conditional effect of PTSD with functioning at low levels of pain and at high levels of pain, right? So if I go through and I take a look at PSYC at low levels of pain, right, for this model here, what am I seeing in terms of evidence for a conditional effect of PTSD on functioning at low levels of pain?
There is evidence against the null.
Yeah, right. So we've got some evidence that, yeah, it looks like this simple slope, we have evidence for that, right? We've got a strong evidence for a negative association between PTSD and role functioning at low levels of pain. Siley, what about my conditional effect of PTSD at high levels of pain?
There is evidence as well for that.
Is there?
No.
Well, if we're looking at, so right here, this is my conditional effect of PTSD on role functioning at low pain. I don't care about anything else in this model, right? But here at high pain, what's my p-value for?
It's not.
It's
I
not.
was looking at high pain and I wasn't looking at the CPTSD.
Okay, right. So, and again, making sure you're looking at the right thing, right? So, yeah, we've got a positive coefficient here, but do we interpret anything out of that? Nah, it's just noise, right? So what we would say is that based on our simple slopes analysis, it looks like we have strong evidence for a negative relation between PTSD and functioning at low levels of pain, but at high levels of pain, we don't have an effect of PTSD, a conditional effect of PTSD on functioning. Okay. Alicia, does this graph make sense? Why might we have an effect of PTSD on functioning at low levels of pain, but not at high levels?
It might be that at the low levels of pain, like the PTSD is more pronounced versus like if people are already at like a higher level of pain and a higher level of PTSD, then it all just kind of jumbles together.
Okay, I think you're kind of on the right track here. When I'm looking at this, it looks like if I'm looking at people with low levels of pain, I'm seeing a pretty clear effect. As my PTSD get worse, if I have low levels of pain, as my PTSD gets worse, CJ, what happens to my role functioning?
Decreases.
It decreases, right? But what if I'm just in intense pain all the time? Does my PTSD matter?
No.
No, it doesn't. And where's my overall level of functioning if I at high levels of pain? Across the range of PTSD. What's that?
Generally pretty
It's below sort of the actual real value for this scale, right? So what we have here is, this is important to be thinking about what this actually means, right? So for people with low levels of pain, yeah, as your PTSD gets worse, your functioning decreases. But if I'm already dealing with high levels of physical pain, I don't know, add PTSD, don't add PTSD, it doesn't matter, because my functioning is just at bottom levels no matter what, okay? And these types of interactions are often what you find in clinical stuff, which isn't relevant to 3 of you, but for the rest of you, right? We tend to think about like, oh, PTSD is going to be synergistic with pain and it's going to go through and then make that relation a whole lot stronger. No, it looks like pain trumps PTSD, and if I'm in physical pain, like it doesn't matter. Like it's just, that thing completely goes away. Okay. So one last thing I'll note, right? So Tamara, you had gone through and calculated these, you went through and factored these by hand, just based alone on sort of your coefficients here, right? Fantastic. You did a beautiful job there, right? But if we go down through and we take a look at your coefficients for your simple slopes at low pain, right? You get an intercept of 23.5 and a conditional effect of PTSD on functioning of 0.413. If we go down through and we take a look at your model for low pain, what do we find in terms of our constant and our coefficient here?
They're the same, but
Yeah, they're the same as what I hand factored out. Same thing for high pain, intercept of negative 3.44, 0.043. What does it look like here? They're the same, right? So mathematically, you're doing this. So this is a nice check to go back through and make sure that and this is why I think it's always beneficial, even though you don't need to, right? You didn't need to do that hand factoring. You could have just ran their simple slope models and then graphed it based off of that, right? But what the hand factoring does is it creates a check to make sure that sort of everything squares up to 0, which is incredibly, incredibly important when you're running these models, okay? All right. So, how are we feeling about this? Questions about this process?
I have a question about the graph.
Yeah.
So if you can go back to it, I think I'm just getting mixed up, but oh, that's a different graph. Never mind. Isn't it?
Oh, there we go.
That's the one I was talking about.
Okay.
So we're talking about low PTSD and high PTSD.
Yeah.
We're talking about the calculation of PTSD from low pain and high pain.
Nope. So what we're doing here is what I did is I went through to create these graphs. I looked at pain at a standard deviation above and below, right? And centered, it's just plus or minus, right? Same thing, standard deviation of PTSD. And so if I go through and I look at my graph here, oops. All I did is I said, okay, here's my simple slope for the conditional effect of PTSD on role functioning at low levels of pain, right? So I go up to here to my Excel. I got 23.520 minus 0.413. If we look up here, and negative 19.76, what value is that?
Like what does it equal, or where did
Yeah.
it come from?
Where did it come from?
Standard deviation.
Standard deviation.
Mental math.
Right. Yep. Same thing here. It's still my low pain function, right? It's a simple slope of low pain, but now I'm just plugging in a standard deviation above.
Got it.
This is just,
Okay.
it's just giving me 2 points on a graph to connect, right?
Okay.
Same thing at high pain, right? Here's my simple slope for high pain, negative 3.43. I guess I got a little bit different, 0.04 times negative, right? And so it's just substituting low PTSD, high PTSD there.
Okay, cool.
Does that make sense?
Yep.
Cool. All right. So what we're going to do now, though, is if we go back through, remember that we had also something that sort of very weak evidence, but something that looks like it might be a signal for an interaction of opiate use and pain. Okay. So what I'm going to do is I've gone through and I figured out simple slopes, tested simple slopes for PTSD and functioning at high and low levels of pain. What I want to do now is I want to go through and I want to take a look at what the effect of pain and functioning is for people using opiates and people not using opiates. Okay, so if I go through and I run my, if I had run my model here, right, and so this is my base model again, right? This is just regressing functioning on pain, opiate use, PTSD, interaction of PTSD and pain, interaction of opiate use and pain, right? What I can do is I can just go through and take my full regression model and this time restructure my equation to get simple slopes for the conditional effect of pain for people who aren't using opiates and the conditional effect of pain on role functioning for people who are using opiates. Okay, and again, we had walked through this in lecture slides. We can go through and plot this out. And so this is what things are looking like if we go through and then in our graph here, we're just substituting for no opiate use, our simple equation for no opiate use, right? So it's 10.47, 12.35, and in my, well, it's not, oh, yeah, this is just standard deviation above and below pain, right? So standard deviation pain 1.34, negative 1.34, 1.34 for people who are using opiates. Same thing here, right? Pain, right? So we go through, run those simple slopes, okay? And we get our graph here, and things are looking good. But Sean, what am I missing off of this?
You still don't know if those slopes are statistically significant or not.
Right. So, and looking at it, does it look like they're different than zero?
Yes.
Yeah, I mean, I can look at them and see that they are. But what I might want to do is I might want to calculate effect sizes, look at the magnitude of effect for both of those for people who are using opiates and who aren't using opiates, right? To go through and explore that a little bit. Okay. So what I'm going to do is I'm going to go up and what I need to do now is what I want to do is I want to get a look at the conditional effect of pain on role functioning for people who aren't using opiates and for people who are using opiates. And Sean, because opiate use is a dichotomous variable, how might I do this?
You've centered it so you have you're going to have an average like user non-user as your base point, I guess.
Right. So right now, right, Sean, help me out. How can I interpret this conditional effect of pain on role functioning right now?
It's for every unit increase of
I guess just more conceptually, yeah. So this is the unique effect of pain on functioning when what?
When all things are held at the mean, and I don't know how you really say the mean of opiate use.
Yeah, exactly, right? Because it's the mean of opiate. It's kind of a weird thing, right? But what we can say is I would in this base model, I would interpret this as the conditional effect of pain on role functioning, controlling for medication use at average levels of pain, or the unique effect of pain on role functioning at average levels of PTSD, controlling for opiate use. Right? We're just kind of taking opiate use out of the equation, so it's like an average effect there, right? But what I could do is if I want to start to get the specific test of the conditional effect of pain on outcome for users and non-users, I can use the fact that all regression is based on zero values to go through and start creating some different terms, right? So what I can do in my data set, opiate use, 1 means use and 0 means no use, right? So what I could do is I can go through and I could go compute, and I already have opiate use at 0, right? So I don't need to worry about that. But I do have a couple of interaction terms to be thinking about, right? And so what I might want to do is I might want to run a regression model that just has opiate use, no use is 0, and then that's going to help me out, right? But I've got interaction terms that involve opiate use that I need to go through and adjust. So what I'm going to do is I'm going to create a new interaction term. Well, actually this is pain, so I don't have to worry about that. I'm going to call this dummy opiate use, or what did I call it in here? Okay. Yes, no. All right, so we'll go call this yes op by pain, right? And so this is going to no opiate by pain. And what I'm going to do is I'm going to take, instead of centered opiate use, I'm just going to go through and just put in my regular old code here, okay? And then what I'm going to do is I'm going to go, well, it's kind of a pain to do this in SPSS, so generally it's just easier to do it in the thing. So if I go to my data and I right click and I hit insert variable, and I'm just sort my opiate use, what I can do is I put 1s for everybody who has use, and 0 for everyone who doesn't. Sean, what did I just do?
You made a reverse code dummy so you know which one is use and one is not use.
Yeah. So I'm going to just call this opioid R, okay? And so now this is just the opposite. And so what I'm going to do now is I'm going to create another interaction term that's yes opiate, and this time it's going to be opiate R times pain, okay? Do people see what I did there? So if I go through and I run this, and I take a look at my data, now I've got interactions of opiate use and pain here, but this interaction corresponds to the situation where no use is coded 0 and use is coded as 1. This interaction corresponds to the variable where 0 is coded as use, 1 is coded as no use. Okay, so if I go down through to my model, so this is my regression model, right? Nick, what am I going to enter? How am I going to modify this to get my conditional effect of pain on opiate use, or my conditional effect of pain on functioning for people who aren't using opiates?
So just take out all the interaction terms about PTSD and the new interaction term that you just made. Throw that in there.
Okay. So what I'm going to do, so this model is going to be simple slope, no use. Okay. And so what I'm going to do is I'm going to, do I want to use centered opiate? Nope. I just want opiate. So I'm just going to plug my original dummy code in there, right? So I've got pain, centered pain, that's fine. Replace opiate use. I want that dummy coded where 0 is no, 1 is yes. Centered PTSD. Pain times PTSD, do I have to worry about that?
No.
Nope, don't need to worry about that. What about opiate use times pain?
No. You want the new one in there?
Want the new one in there, right? So I'm going to take my variable that I created for no opiate use times pain and drop that in, okay? Then I'm going to sort of copy this model again. All right, Nick, you're on a roll. Help me out. Is pain fine?
Is it fine?
Yep, 4, and we want this to be simple slope use. Okay. So for this, is pain fine in this equation?
Yeah.
Yeah, pain is fine. What about opiate use?
No, you don't want the. Or wait, yeah, no, it's fine.
Is it fine?
Nope, it's not fine.
Right. Gonna put my reverse coded up. Why do I want my reverse coded opiate use in there?
Because then that corresponds to people that have use.
Yeah, 0 corresponds to people who are using, right? PTSD, is that fine?
Yeah.
PTSD is fine. Pain times PTSD?
Sure.
That's fine. And then my new interaction term here, right? So what I've done is I've gone through and restructured my regression model so that I'm regressing role functioning now on centered pain, but my dummy code for opiate use, where 0 corresponds to no use, times PTSD times pain, and then my interaction using my dummy code of my opiate, where 0 is no pain or no use. Then I'm just going to run the exact same model, except for just that code is flipped around. For this one, 0 corresponds to use, right? This is fine, and then I'm substituting interaction with the code where 0 equals use, 1 equals no use. Okay. So if I go through and I run these models, okay. Go through, get rid of that, because this is all the same, right? The model, this stuff doesn't change at all, right? This is all the same, but now I just got two models here. And first thing I'm going to do before I jump in and try and interpret anything is I'm going to maybe go back through and take a look at this relative to my original model, right? Because if I'm looking at my original model, CJ, what should I see as being the same across my simple slope models and my overall model that I ran here?
Shouldn't the this stuff for pain, or I think those interaction terms, aside from I guess the new one, should be the same. So like pain times PTSD.
Okay.
Pain
Yeah.
PTSD be the same.
All right. So my interaction terms are always going to be identical, right? My higher order interactions, my highest order terms are going to be the same. Doesn't matter where the 0 point is on my scale. And so if this is our original model we ran, does it look like we did a good job in terms of setting up our stuff here? Yeah. Yep. You'll notice we get a negative on this interaction term for yes pain, but that's just a function of us switching that dummy around. The value for my across my models for PTSD and pain, 0.17, 0.17, 0.17, 0.4 or 4.603, 4.603, 4.603. That's all the same. Okay. And what about coefficients for my effects that that I don't care about, right? So this is going to be opiate use, PTSD, opiate use, negative 0.861, negative 0.861, 0.861 again because we just reversed that dummy code, but that's the same. Coefficient for PTSD, negative 1, negative 0.185, negative 0.1, negative 0.185. That's all the same. CJ, what was the purpose of running these simple slopes analyses? What was I interested in?
We're looking at pain for people who use opiates and people who don't.
Right. And so do I see my my conditional effect of pain change across these two models? Yeah, I do, right? And I should, because if they don't, I've done something wrong. That's the whole reason I'm running these, right? And so I see my intercept changes because I've changed because I've changed sort of where the 0 point is, and I see my conditional effect, my target conditional effect change. And so here, it looks for people who are using, who are not using opiates, right? Because this is the effect of pain on role functioning when everything else in the model is held 0. And in this model, opiate use at 0 means no use, right? So for people who aren't using opiate use, or who aren't using opiates, we see this is going to be the conditional effect of pain on role functioning for people who aren't using, holding PTSD constant at the mean, right? And so we see a standardized coefficient of negative 0.641, which is really strong. And we have strong evidence against the null here, right? Here, we're looking at the conditional effect of pain on role functioning for people who are using opiates at average levels of PTSD. And here's my conditional effect here, right? We see, again, a pretty strong coefficient, but less steep than sort of with no use. Okay, but everything else is the same. And if I go back through and I take a look at my simple slopes that I calculated by hand for no use, intercept 10.468, right? Within rounding error. Simple slope for pain, 12.348, 12.347. For people who are using, 9.607. Simple slope, 0.74, right? Everything adds up. Everything maps onto what I had calculated by hand. And so it all sums up together. And so what I would say here, based on this model, is that it looks like that pain holds a unique association with functioning for both people who are using medications and who are not. But it looks like the effect of pain on functioning looks to be stronger, tighter. There's a stronger connection there for people who aren't using meds as opposed to people who are. Does this make sense? What do you think, Chris M?
Yes, generally speaking it does, because we can see, but it would be valuable to have effects like you had said earlier.
Mm-hmm. And so the other nice thing too, when I'm going through and I'm running this, here I have the effect size for my conditional effect of pain for people who aren't using, right? Here's my partial correlation, here's my part correlation. For people who are using, here's my partial, here's my part. Here's a standardized coefficient. So they're both pretty strong effects. But if my pain medication is doing something, it should make that connection between pain and functioning weaker, right? It's still there, right? I don't know how effective it is. And my marginal effect here suggests that maybe opiate use may impact the nature of the relation between PTSD and pain, but I don't have a whole lot of evidence for that, right? Looks like there might be something here, but I'm not probably going to bet the house on this. Okay. Questions about this? How are we feeling? All right. So this is a sort of a tricky thing, okay? But when you're working through these models, and this is going to extend out to anybody who is going to end up going in and looking at multi-level models or things along these lines, the number one thing to think about when you're playing around and modifying your regressions is to be thinking about, what does 0 mean? Because your coefficients are always going to represent the unique effect of X on Y, holding everything else constant at 0. So in your head, you need to be thinking about, for all of my other scales, what does 0 mean, right? Because then, instead of just saying this is the unique effect of pain on outcome, holding everything else constant at 0, you can start to actually give that an actual interpretation. This is the effect of pain on outcome at average levels of PTSD for people who aren't using opiates, right? Or this is the unique effect of PTSD on functioning for people at average levels of pain for those individuals who aren't using opiates or are using opiates, things along these lines, okay? So whenever you're evaluating research or conducting your own research, any categorical variables you have, any dummy codes, going to be very, very, very important that you know what 0 means, what 1 means, and how that impacts your interpretations. Okay. So for this, this model I ran here. Okay. So this model here, and this is my model that I ran looking at pain, opiate use, and PTSD and the interaction of these two without centering opiate use. Could I have used this as my starting model? What do people think? Did I need to center opiate use, or could I have just started with this?
I think you used that for one part of the model.
Yeah, I could have started out with this, right? But the reason for that I like to start, and it would have saved me time, because then if I would have just not centered opiate use, and then just calculated my interaction terms from there, then I would have started with my simple slope, right? But the problem going into this, I don't know which one of these interactions are going to come up, right? And so by centering opiate use, it says, all right, controlling for opiate use, what's the unique effect of this and that and the other thing, okay? Because if I just run this model, Sean, what is this coefficient correspond to?
It's pain only for those folks that are using opioids.
Who are not using opiates.
Who
are not using opiates, right? And so then this effect here is my effect, or sort of the difference between people using opiates and not using opiates, holding pain and PTSD levels constant equal at 0, right? So this is just basically, it's like an ANCOVA. Like this is literally the difference in functioning score for users and not users, holding pain and PTSD constant at 0, okay? And then what's this effect of PTSD correspond to, Sean?
It's the effect of PTSD on role function, holding all things constant, and for people with opiate use.
Without opiate use, right? So this is the effect of PTSD on role functioning at average levels of pain for people who aren't on opiate medications, right? But I've got an interaction here between opiate use and pain. And so what I've done is I don't know, these conditional effects maybe aren't what I am interested in, right? Depending on whether or not this comes up as reliable or not, right? So my general approach for just straight dichotomous indicators, I kind of like, I like centering those. Not that 0 is a meaningful value of anybody, because you're either here or you're here. But when you go through and center those, what it corresponds to is just holding that constant so that I can go through and take a look at that, right? And then if opiate use doesn't have any impact, then it doesn't matter. But if it does, it's saying, okay, if we control for this, what's the unique effect of other stuff going on in there? Okay. All right. Questions?
So Joshua, in some of the readings that you had, they're talking about always having to have a relationship between the two predictors in order to have a moderating or a mediating effect. Where do you come off on that one?
Okay, so that's a different thing. That's going to be talking about mediation. That's a different process. Hold on to that. We'll talk about that next week. Okay. But you bring up a good question, and it comes back to this idea. Sometimes you will hear people say, well, you have to have, your variables have to be really, you have to have an effect. If you don't have a conditional effect, right? If you don't have an effect of pain in your main model, then you can't have a moderated effect or anything like that, right? Or if your variables aren't correlated with one another, then you can't have a moderated effect. That's categorically false, right? Because again, what we end up with Oops, I'm not. Because again, what we end up with are situations where, right, just my base model, I might have something like that. I don't know. That doesn't look like there's any effect right there, right? But as soon as I enter my moderator, I get something that looks like this, and at low levels, oops, something that looks like this, I have a crossed effect. Now, if I'm not accounting for that interaction, it looks like I have no effect at all, right? But as soon as I throw that in there, that comes up, right? So moderation has no, so your interaction, your main effect, your main effects and things like that, and your associations between your variables has nothing to do with whether or not you have a moderation effect there. Mediation, it starts to become important, but for moderation, we don't have to worry about it. Okay. All right, questions? Okay, cool. Let's go through, take a 5-minute break. Let's try and be back by 3:21-ish, and then we'll jump into looking at these models within sort of categorical indicators. Sound good? Cool. All right. Thanks for everybody. Yeah, I guess that 5 minutes wasn't super long. Maybe that's not a reasonable break for anybody to do anything with, but yeah, we'll take another quick one sort of as we move forward. But I guess any questions before we get into sort of the next material stuff? Okay. I'm excited. You know what? I'm going to tell you right now. This stuff we're getting into, you guys are the first ones to ever run into this. This is never before seen lecture slides. So this is, like, CJ's excited. I can only see somebody like Chris M doesn't look like he cares. But Alicia looks happy about it. All right. So we talked about standardizing solutions, right? One of the things, we didn't talk about this a whole lot, but remember that for your interaction terms, that your standardized effects for your interaction terms are not technically correct, okay? You have to get those, your standardized coefficients for your conditional effects are fine, but for your interactions, they're not. And this is because of how SPSS and other models factor them out. So to report appropriate standardized effects for your interactions, you have to calculate those, remember, by taking the z-score of your outcome and the z-scores of all your variables, and then creating interaction terms with the z-scores, rerunning everything, in order to make those things precise. So just keep that in mind in terms of putting these models together, okay? But so what we've talked about in terms of, up to this point, talking about looking at our simple slopes analyses by recentering our rescaling our moderator so that 0 corresponds to one standard deviation above and below the mean, right? This is standard in psychological research, and the standard deviation above and below kind of makes sense because it's within that range. It's a high level, it's a low level, but it's at a level which is going to be represented in your sample, things along these lines, right? But you will see people criticize a simple slopes method, or people will call this a pick-a-point method, because what you're doing is your analysis is just presenting the conditional effect of x on y for just two and arguably semi-arbitrary values of your moderator, okay? If your moderator is continuous, right, like our first effect is, when pain was the moderator of the relation between PTSD and functioning, conditional effect of x on y could take an infinite number of values, right? If pain is a true continuous variable, there's a whole range of values that might look like, right? So again, if we pull this up, if this is x and this is y, right? And we say, here's standard deviation above, here's standard deviation below, right? But we could also go 2 standard deviations above, or we could go a half a standard deviation, or we could go any number of slopes here could be picked, right? there's an infinite number of conditional effects with a continuous moderator, right? And what we do with our simple slope is we just pick a value for a high and a low level, but there's lots of other variables that could be interesting, or sort of values that could be interesting. And what this simple slopes analysis doesn't do is it doesn't tell us where the boundary conditions are on this conditional effect, right? So again, if I go through and I take a look at, this is my simple slope, right? And I say, okay, and here's X, here's Y, right? And I see an effect here, an effect here. And this is +1 standard deviation, and this is -1 standard deviation, okay? So, Chris C., I'm finding that I don't have at standard deviation below the mean of my moderator, I'm not finding a conditional effect of X on Y, right? It looks like it's just noise, but I am finding an effect, evidence for an effect at a standard deviation above, okay? What point do I transition from not having evidence to starting to have more evidence, at least in terms of conventional criteria for interpretation?
Evidence of like an interaction effect?
No, evidence. So at what point, let's say this is my simple slope at a standard deviation below, and that's not different than 0. Standard deviation simple slope of X on Y at a standard deviation above, and I do have evidence of a positive effect here. At what point does this evidence for this 0 effect turn into positive?
I'm not really sure what you're getting at.
At what point does this simple slope turn into a positive slope as opposed to being 0? See what I'm saying?
Like, when does it go up?
Yeah, so let's say this is P equals 0.236,
Okay.
and this is P equals 0.002. Okay. At what point in this range, what value of my moderator do I have to get to make that a positive slope, or evidence of a positive slope?
Your moderator to get it to be a positive slope.
Yeah.
I'm not sure.
Yeah, me neither, because it doesn't tell me that, right? Basically, what I've done is I've chosen 2 values of my moderator, right? And I've looked at and tested the effect of my simple slope at low levels and at high levels. But at some point, right, and in this infinite number of possible slopes, there's going to hit a point where I do have evidence, sort of my moderator, and if we're looking at sort of traditional statistical significance, at some point that simple slope is going to become significant, right? Can I tell that from my just picking my 2 points? I can't, right? I'm kind of limited in sort of the information there, right? And so what we'll see is this the simple slopes analysis that we traditionally use being criticized because it's not telling me the boundary effects of my conditional, or the boundaries of my conditional effect. At what point does my conditional effect go from being positive to being not different than 0, or what does it switch over from being positive to negative? This is very difficult to determine within the context of sort of our conventional approach, right? So an alternative is what's known as a Johnson-Neyman procedure, okay? Instead of just plotting simple slopes for 2 or 3 different values that we choose, what we do with a Johnson-Neyman procedure is we look at the conditional effect of X on Y and corresponding confidence intervals across a whole range of values of M, okay? What we do is we have the computer, and this is output from Stata, just because Stata does this easily. You can, with process, you can coerce SPSS to do it, but it's kind of a pain. But what we see here within this output, what I've done is I've looked at conditional values of X on Y for values of M ranging from 0 to 9. So my moderator here, the range of my moderator is 0, min, max is 9. And what I've done is I've told this program at every 0.05 intervals, starting at 0 and ending at 9, at every 0.05, run the simple slope for that value of the moderator. Okay, so here is value of here's my simple slope of x on y for moderator equals 0, moderator equal to 0.05, 0.1, 0.15, 0.2, right? And so what we get is a long list of simple slopes and corresponding p-values and confidence intervals. And we see that low levels of the moderator, starting at 0, I have clear evidence of a non-zero effect. But by the time I get up to high levels, somewhere in between here, it stopped. I stopped getting evidence for this. Okay. So now going through and reporting this in a table with 181 values would not be tenable, right? But what we can do is we can go through and plot this out. Okay. So in this example, what we have, and this is, I stole this from, I'm making Layla do this for her thesis. So this is all stolen from Layla's thesis data. What we have here is an association between PTSD and social functioning at high and low levels of empathy. So we had people come into the lab, complete an empathy task, and what she's looking at is the moderating effect of empathy on the relation between PTSD and social functioning. And what we see here is our traditional simple slopes analyses. So this is the effect of PTSD on social functioning at low levels of empathy. And this is the association between PTSD at high levels of empathy. Okay. So at low levels, we have very, very strong evidence of an effect where we see for every 1 unit increase in PTSD, we see a 0.163 or 1.63 reduction in corresponding functioning associated with p-values, S, Bayes factor, like we would normally do, right? However, at high levels, standard deviation above around 8, we have a coefficient of our conditional effect of PTSD on functioning of negative 0.29. Here's our confidence bound. Clearly, no convincing evidence for a non-zero effect here. S is 1, Bayes factor 1.03, right? So this gives us this conditional effect of pain on functioning at low and high levels as indicated by a standard deviation above and below, but there's a lot of stuff that we don't know, right? What we could do instead is create a Neyman-Johnson or a Johnson-Neyman plot where we go through and we take these values here and we just plot those out along with corresponding confidence intervals, okay? So what we have here on the x-axis is your moderator. This is empathy, right? And this, on the y-axis, is your conditional effect or your coefficient for your conditional effect of PTSD on functioning, okay? And what we see is we've got a plot looking at the conditional effect of PTSD the conditional effect of PTSD on social functioning across the range of my moderator, along with corresponding 95% confidence intervals. So here with my simple slope, I looked at a standard deviation below and a standard deviation above, values of 3 and a value of 8. Here's a value of 3. CJ, do I have evidence of this as a non-zero effect?
Yep.
Yeah, why?
Your confidence interval there isn't crossing the 0.
Exactly. We've got I've included this reference line here at 0, right? And so the lower limit, or I guess the upper limit for this effect is quite a ways off of 0, right? So we've got very clear evidence of an effect, right? And what about, and here, tomorrow is my coefficient at a standard deviation above. What is this? How am I interpreting this here?
There's also evidence for a non-zero effect.
Is there evidence for a non-zero effect for my effect here? So if I look at, so here's my point estimate. Where's my upper confidence interval, or the upper bound?
Just hitting it. It's above 0.
Right, that was a good joke. I like it. But yes, right? Here we don't have evidence in effect because my confidence bound contains that 0 point, right? So at high levels of empathy, the unique effect of PTSD on social functioning could be anywhere from a positive value to a negative value, right? So what I might want to know is at what point, based on the data that I have, do I stop having, at least in a traditional sense, evidence for a unique effect of PTSD and functioning, right? And what I can do is I might say, all right at this point, right here, this is where my upper bound hits that 0 point, right? So for this point below, I have evidence of a unique effect of PTSD and functioning for levels of empathy at this point and below. And if I go through and I take a look at my output, this point corresponds to roughly a value of empathy of 6.75, right? And at this point, this is my coefficient for the unique effect of PTSD and functioning. Here's my confidence bound. Here's my p-value, my S, and my Bayes factor. Okay. So Chris, so this is the effect in my data, at which point I stop seeing evidence for a unique effect of PTSD on functioning. This is the point at empathy 6.75. This is where the exact point, at least in these data, will say that I've stopped seeing an effect. If we're using p less than 0.05 as a criterion. What concern might I have with this?
Chris?
Yeah, Chris M.
Okay, that it still is kind of arbitrary to just pick out because you're using the upper bound.
Yeah.
There's no guarantee that it's always going to hit that upper bound because we can also see that the lower bound is pretty far down there as well.
Yeah, exactly, right? This is the point for this data, right? If I were to run a replication of this, same people, or not same people, but different sample, same design, everything else, Siley, would I find that 6.75 is exactly the mark that this conditional effect ceases to be statistically significant? No, it's going to jump around, right? So maybe what I want to do instead is I want to say, all right, at what point do I see something that starts looking like strong evidence for a unique effect of PTSD on functioning, right? And so maybe if I do that, I go through and I take a look at my output, we'll say at a value of a moderator of 6.15, this is where I start to get a p-value that's associated with a Bayes factor above 10, which maybe I use my criteria for something of strong evidence against the null, right? And so I say right here at 6.15, that's where I'm seeing strong evidence, continue to see strong evidence for an effect. Okay? But then maybe I say, well, I don't like 6.15 because 6.15 isn't a real value of my moderator, right? This is 0 to 9 in increments, sort of whole number increments. So I say, what is it at 6? Well, at moderator value equals 6, really close, right? But here's my effect, okay? And so I might say, all right, for levels of 6 or below, I have evidence for a unique effect of PTSD in functioning. But above that, evidence starts to get questionable, right? But if I look at my moderate or my average value here, my average value is about 5.5, right? And so I could go through and I could take a look at, for empathy at score 5, what my effect is, right? And go through and take a look here, right? And so what we've got with this Neyman-Johnson plot is an approach that's a little bit trickier to interpret, but it contains a lot, sort of considerably more information than just choosing our two slopes here. Okay, so this is standard for psychological research, and this is no one will get upset with you for, well, no one should get upset with you for this, but if you start to have questions, and particularly if we're working with variables that have real sort of impact and meaning, and the question starts to become, at what point over the course of this moderator do we stop seeing an effect or evidence of an effect? This ends up being a much better approach to identifying where stuff is going. Yeah, Chris.
So essentially, we're also just like we end up picking a point where afterward we're saying that the effect is not significant. So isn't that sort of counterintuitive to the original reason? Apart from the plethora of information that we provide with this plot, isn't the other argument that we're still just picking a point that we're going to cut off at? Like we have 3 here, and we end up picking 6.
Yeah, and so this piece is just for demonstration purposes. Like you wouldn't necessarily go through and do this, right? But for me, as I'm looking at this plot and trying to understand kind of what's going on, what I know for these data, that average levels of average empathy scores in this sample were about 5.5, right? And so what I'm seeing based on these data is that once we hit about 6, I start to lose confidence that I've got a replicable effect or a strong effect once we get above 6. And if my average is 5.5, if I'm looking at this, I'm saying, well, it looks like based on this setup and this design, it looks like I have evidence for a unique effect of PTSD and social functioning. And this is a negative effect, right? Because these are all negative. It looks like PTSD symptoms hold a negative relation with social functioning, and for people who are scoring about at the mean or below. But once we get too much higher than the average level of empathy of people, now all of a sudden this the inverse relation of PTSD and functioning tends to go away, right? And so I can use that just as kind of a general interpretation of this to start to make a much more nuanced interpretation of how this actually plays out, right? So for you, if you're looking at an association between sort of exercise and sort of symptoms, and sort of at what point does this start to become sort of problematic or not problematic and things along those lines. So just a lot more information available to us. How we choose to use it is very different. I could see someone saying, oh, at this point at a value of 6.75, that's the value at which we stop seeing an effect. Well, that's not smart because this is just one sample out of an infinite number, right? And it's going to jump around, right? So, but if we start usually using our S's and our Bayes factors to say, based on these data, looks like about 6 is probably where we start to have some reasonable idea, right? You'll also notice that these confidence intervals are curved. Why is that, Ignacio?
I believe it is because how the normal distribution goes in the parameter you are estimating.
Yeah.
And it comes to this interval.
Yeah. Where are we going to have the most information about empathy?
4.5.
Yeah, well, probably around the mean values, right? As we start to get farther and farther out, right? We're probably not going to see a whole lot of people with values of 0, probably not a whole lot of people with values of 9, right? So as we start to get farther out there's less information, and we see that confidence interval start to decrease. Thinnest towards the center of the distribution, and then sort of going out here, right? And so using this effectively to start thinking about, as opposed to just sort of at 2 levels, which is fine, right? But this is giving us an approach that gives us quite a bit more information. Questions on this? Okay. So again, you can use process, and we'll talk about process. You can use process to coax out Johnson-Neyman plots. It requires some work, but you can get it done. Stata, it ends up being pretty straightforward. Here is your regression model in longhand, or in actually shorthand with what we've done here. Layla just had a lot of variables in this model. But here what we're doing is we're asking for margins or sort of effects, specified effects for a slope of my conditional variable at levels of my moderator ranging from low to high at the interval here right? And so then it goes through and it saves it to different stuff. And so here, if anybody is interested in watching me walk through sort of one of these to kind of see this process, you can go through and take a look here. But maybe most relevant to anybody using Stata in their work here. Okay. All right. Any last questions on Johnson-Neyman procedure? I'm not going to have you do this. Just want to present it as sort of an alternative to sort of giving a little bit more information. Okay. So to this point, we've talked about analyses using continuous variables and dichotomous indicators. Okay. But sometimes we're going to have research questions that involve multichotomous indicators or categorical indicators. Okay. Now we can't just plug a categorical indicator into a regression model, right? Let's say I have 4 conditions, right? CJ, you're running an analysis, a study, and you got 4 different people randomized to 4 different conditions. You can't just plug those in as 1, 2, 3, 4 because regression is going to treat it as a linear scale when it's not, right? And it's not going to be interpretable. But what we can do with the proper coding is we can look at any combination of categorical and continuous variables with the proper coding within a standard regression model. So if I have a categorical variable with 3 or more levels, what I can do, and now there are other options, what I can do is I can start dummy coding these, okay? And if I dummy code, what I do is I create a G-1, so number of groups -1, binary codes, 0, 1 codes, to start comparing my individual categories to a specified reference group. Okay, so this is an example right out of Aiken and West, but it's a good example. So let's say I'm interested in the relation between education and income. Okay, and my question is, what's the unique association of degree and GPA with starting salary? And then what I then want to know is, does degree program moderate or influence the relation between GPA and starting salary? Okay, so what we've got here is a hypothetical set where we've collected data from a bunch of students with 3 different degrees. We got people with a liberal arts degree, we got people with an engineering degree, and we got people with a business degree. Okay, can I enter this into my regression model as just 1, 2, 3 and have anything that's interpretable? Nope, I can't, right? But what I can do is I can take this degree variable and I can break it into 2 dummy codes, okay? So I've got 3 categories, so 3 minus 1 is 2. So what I have is I can create, for this example, I'm going to create 2 dummy codes. I'm going to create a dummy code for engineering, where people who have an engineering degree get a value of 1. If people have liberal arts or business, they get values of 0, okay? Then I'm going to create a dummy for business, and anybody who has a business degree gets a 1. Anybody with a liberal arts or an engineering degree gets a 0. And in this, liberal arts is my reference group. So if I go down through and take a look at this little information here. So here's my degree: business, liberal arts, business, engineering, business, liberal arts, right? So for my dummy for engineering, if people have an engineering degree, they get 1s, everybody else gets 0s. Here for my dummy for business, if you have a business degree, you get a 1, everybody else gets 0s, okay? And then liberal arts is my reference group for this analysis. With the strategy that I've used, everything gets compared to those individuals with a liberal arts degree. People see how I set this dummy code up? Okay, so what I'm going to do then is I'm going to go through and I'm going to regress salary onto my 2 dummy codes, okay? And if I do that, so I've regressed, Y is my starting salary, and I regress it onto my dummy code for engineering and my dummy code for business, okay? And when I do that, this is the equation I get, okay? So I get 21,000 plus 6,999 times engineering plus 3,000 times business. Okay. And so if I go through and I take a look at these coefficients, I see that my interpretation of my regression intercept here is going to be the mean salary for people in liberal arts. Chris C., why do I interpret my intercept as the mean salary for people with liberal arts degree?
Is it because the dummy variables make it 0 both times, so it's kind of whatever's left over?
Exactly. I could come through and give you a high five. That's exactly right. With the way I've set this dummy up, right? And I look at my equation. So my equation is 21,000, right? And so this is the expected starting salary holding all other variables constant at 0. Well, if I hold engineering dummy at 0 and business dummy at 0, who am I talking about? People with a liberal arts degree, right? And I can go through and what I see is that then for people with a liberal arts degree, that's their expected salary based on this model, okay? So I see that my coefficient B1 here, this is going to be the difference in the mean salary for engineering versus liberal arts, okay? Because if I go through and I have, here's where I start, and then for B1, this is engineering. If I'm talking about engineering, then engineering is a 1. And if I'm an engineer, what's my dummy for business? Chris?
So if you're an engineer, what's your dummy for business?
Yeah.
Like the coefficient or like 0?
The value here.
Oh, 0.
0. So that goes away, right? And so what I see here is that my expected value for my engineers is going to be 21,000 plus 6,999, right? And so what I see is this coefficient being the difference between my expected value for liberal arts and my expected value for my engineers, right? And if I add my intercept B0 plus B1, that gives me my mean salary for engineers, right? So here's my mean salary for engineers, and about $7,000, that's the difference between these two, okay? Same thing, B2, this is the difference in my mean salary for business versus liberal arts. And if I add this plus this, that gives me my average salary for business, right? Because if I'm a business major, then my coefficient for engineering is 0. That goes away. What I'm left with is 21,000 plus 3,000 times 1, right? And so this is the difference here. Okay? And so my overall regression model is testing the hypothesis that salary does not differ across degree. Okay? Nick, what have I just essentially run here?
You basically run a version of an ANOVA.
Yep. Not a version of an ANOVA. I've run an ANOVA. This is an ANOVA model, right? With the proper coding, my ANOVA model. Now, if this was the question I had, you should probably just run this as an ANOVA because it is more straightforward and people like it, right? But any model that I can run in an ANOVA framework, I can also run as a regression, which gives me additional flexibility. So you're exactly right. What I've done here is I've basically run an ANOVA model with a specific contrast comparing engineering and liberal arts and business and liberal arts all put together, right? And so if my R squared is some non-zero value, it tells me that my overall model is statistically significant and that degree program does in fact impact salary across levels. Okay. People see how we set up these dummy codes and why those are working out? Okay, cool. So let's take this and say, okay, well, I'm seeing differences in expected starting salary across degree programs, which, are we shocked by this? Nope. Your psychology degree at the highest levels gets you a starting position as a graduate student for poverty wages. So it's different than coming out with an engineering degree and making like 6 figures, you know. It's life choices, hashtag. But maybe what we want to do now is say, does GPA make a difference, right? Because what we want to do is we want to go through and control for the fact that sort of different people are going to have different levels of GPA. So what we do is we go through and we run regress starting salary onto our dummy for engineering, onto our dummy for business, and then our centered GPA variable here. Okay, and this is the equation that we get. So our intercept, 20,978, coefficient for engineering, coefficient for business, and then our coefficient for centered GPA. And then we get our set of coefficients here. Our coefficient, our intercept here, this is going to be the mean salary for liberal arts majors with GPA held constant at 0. Okay. And Alicia, what does GPA held constant at 0 mean?
It means you're just looking at that mean salary between the engineering and the liberal arts.
Okay. Well, if GPA is centered, what does the value of GPA equals 0 mean? If GPA is centered.
You're looking at the salaries. You're looking at the mean of the GPA?
Exactly. So again, my coefficient, if I'm interpreting literally, right? This is the mean, the expected starting salary for liberal arts majors with GPA held constant at 0, which means GPA held constant at the mean. Okay. My B1 coefficient for engineering is still the difference in mean salary for engineering versus liberal arts, but controlling for GPA, holding GPA constant at the mean. My coefficient for business is the difference in mean salary for business and liberal arts, holding GPA constant at the mean. And then my B3 coefficient here, this is the change in expected salary per unit change in GPA for liberal arts. CJ, why is this specifically the mean, the change in expected salary per unit change in GPA, specifically for individuals with a liberal arts degree? Set at 0. Yep, it's set at 0. Perfect, right? And so if I'm interpreting this is unique effective exon, like anytime you're looking at any regression model, if you have like tattooed somewhere where you can see it, this is the unique effective exon Y holding everything else constant at 0. You're always going to be right? The question then becomes, what does 0 mean, right? So this is going to be the unique effective GPA on starting salary with engineering and business held constant at 0. And if engineering and business are held constant at 0, who am I talking about? CJ? The liberal arts, right? So if we go through and we graph this out, what we're seeing is the unique effective GPA and starting salary for individuals in liberal arts, business, and engineering. Okay. Sean, what are you noticing about these slopes?
They're all parallel, so there's no interaction effect.
Yeah. Could there have been an interaction effect? Could I have detected an interaction effect here?
You couldn't detect it, but
yeah.
Probably.
There probably is. Why might you think that there might be an interaction of GPA and degree?
Because like a high GPA engineer, you would trust more than a very low GPA engineer.
Right. Maybe. Or anybody here have friends or relatives who are engineers or went through engineering programs?
I did.
Yeah. What do C's get you in engineering school? A job, right? Those courses are pretty intense, right? If you're getting a C, that's awesome, right? Like you might have the highest degree thing in the grade in the course, right? So we might expect that GPA might not mean the same thing across different degrees, right? And so what we might want to do then is then look at the interaction, right? Because what I can do if I start to include multiplicative effects, what I'm now looking at is differences in the relation of GPA and starting salary across different degrees, okay? So if I do this, I'm regressing starting salary onto my dummy for engineering, my dummy for business, center GPA, and then my dummy for engineering, a GPA, dummy for business, and GPA, okay? This is the thing. Everybody, look at me directly in the eyes, virtually. As soon as you create dummy variables, dummy codes for a categorical variable, do not center your dummy codes. That's going to screw up the whole thing. Like if you got like a straight up binary variable, just male, female, condition 1, condition 2, something like that, cool, you can center it, controls for it. Do not try and center a dummy code. It's going to screw everything up. They're going to render it non-interpretable, okay? So what we've got here is our 0-1 variable. We've regressed outcome onto our 0-1 variable for engineering, 0-1 for business, center GPA, and then the interaction that we'll create of engineering, GPA, business, GPA, but we're not, the only thing we're centering here is GPA. When we get into dummy codes, do not center those because it's going to screw stuff up, okay? So we do that, and we get our a model here. And so when we take a look at, we can go through and calculate simple slopes based on factoring this equation out. And with this, it's actually pretty easy, okay? So if I want to look at the simple slopes for my folks who have a liberal arts degree, it's just going to be 20,982 plus my coefficient for GPA, right? Nick, why does that make sense?
That makes sense because that's your reference value, which means you're holding all the other groups at 0.
Yep. And so if I'm talking about if I hold 0 for business, that drops out. 0 for engineering, that's gone. That's gone. That's gone. What I'm left with is my intercept plus my coefficient for GPA, right? So as we were talking about before, if I'm not centering my dummy codes, my main model just gives me the conditional effect of my predictor with outcome for whatever my reference group is, right? I could also look at my conditional effect for the relation of GPA with outcome starting salary for engineers. Again, just drop down my intercept. Here's my coefficient for engineering. 1 goes in for engineering, so that just drops down to 7065 plus coefficient for GPA minus engineering goes in here, minus 667 times GPA. That drops down here. Business is gone because that's 0. Gives me a simple slope of 28,047 plus 123 GPA. Same thing if I do business, and this is just substituting zeros and ones into here. Stuff falls out. Gets me my simple slopes for business. And so what I've got here is my intercept, mean salary, expected salary for liberal arts, holding GPA constant at the mean. This B1, difference in mean salary for engineering versus liberal arts. B2, difference in mean salary for business versus liberal arts. 3 here, expected change in salary per unit change in GPA for our liberal arts majors. B3 plus B4, association between GPA and salary for engineering. B3 and B5, association between GPA and salary for business. Okay. People see what we did. This is just basic algebra, substituting zeros and ones in to get our simple slopes. People see how we went through and did that? Okay. And so if I want to go through and I want to test these simple slopes, all I need to do, similar to what we did when we were looking at opiate use, what I'm just going to do is I'm just going to change around the reference category for the dummy codes, right? So my simple slope for liberal arts, this is just a test of the coefficient B3 in my original model, okay? My coefficient here for GPA in my original coding scheme, that's just my simple slopes for liberal arts, right? But if I wanted to look at my simple slopes for engineering, what I would just do is I would just create a couple of new dummy variables. I'd have a dummy variable for liberal arts, where 1 is liberal arts and 0 is engineering business. And then I'd have a recoded business dummy, where 1 is for business, 0 is engineering and liberal arts. And then I just run my new regression model with that dummy instead of my original dummy. And my coefficient for GPA is going to be the unique effective GPA and starting salary for my engineers. And if I do it again, this time recoding, now I've got my dummy for liberal arts, where 1 is liberal arts, 0 is business engineering. A revised dummy for engineering, where 1 is engineering, 0 is business and liberal arts. Rerun my model. My coefficient for GPA is now my simple slope for business. Okay, so we're just playing around. Whatever your reference group is, your conditional effect is the unique effect of that variable on your outcome for whatever your reference group is. So to test our simple slopes, we just recode this to whatever whatever group we want the simple slopes for. We just switch around our dummy codes, so that's the reference group, and then just rerun our models, and then that just keeps coming up. Okay, and so what we see in this model, we see here some association between GPA and starting salary for liberal arts, a stronger association between GPA and starting salary for business, but functioning no association between GPA and starting salary for engineers. And if we know about how these things work out, people aren't systematically getting engineering degrees with 4.0s. It's not to say it never happens, but that's just not an expectation of those courses. Super intense, and you just have to get through them, right? Liberal arts, sort of different stuff. Looks like, at least in these data, is suggesting that business maybe has the strongest relation between GPA and starting salary, but it looks like we're seeing differences in the unique effect of GPA on starting salary across these different groups. Okay. So, Tamara, could we run this model in a traditional ANOVA framework? What's that?
Yes.
Maybe. Why? What would make it difficult to run, though, like in a straightforward factorial ANOVA?
Well, since we're looking at the effect of GPA on the
Yeah. We've got a continuous variable, and a continuous variable that is sort of has a meaningful range, right? And so it would be very, very difficult to plug this into a regression model because regression doesn't fit. I need to have categorical variables, and I can look at interactions, but the interactions I'm looking at have to be between categorical variables. And what I'm really most interested in is this association between GPA, which is continuous, and outcome. And so our ANOVA models come up short. But what we can do is use our regression models to go through, run this, and we end up in a pretty good spot. Okay. Questions on how we went through and set this up and sort of going through and interpreting these models? Cool. All right. So one thing we might want to take a look at, and sort of this is a conceptual issue. Sean, this gets back to some of the stuff that I had emailed you about and some of your questions about, do these interaction terms fall on a T distribution? Yep, we treat them as variables the same as anything else. But one of the things that we might want to be aware of is that if I have variables that are highly correlated, so my predictor and my moderator are highly correlated with one another, what I see in my regression model as strong evidence of a moderation effect might actually be picking up on what's a curvilinear effect between my predictor and my outcome. Okay? If X and M are super highly correlated with one another, the interaction term of X times M is about the same thing as X squared, right? And if I'm looking at the relation between X and Y, and if I have some sort of curvilinear relation, this might actually be what's going on in the data. But if I model this as an interaction between X and some highly correlated moderator, the value I would have got for x squared that I would get in a properly specified model is going to be very similar to the value that I would get with sort of my interaction. And what I might do is I might end up with something that I'm saying is a moderation effect, when it's really not. What's actually happening is I'm just picking up on the nonlinearity of my predictor and my outcome. Okay, so most of the time, tomorrow, when are we gonna? If X and Y are related in this way, where am I gonna pick this up? Where am I gonna see this? Hopefully, in my process. Yeah, but even before I get to my interaction, what should I be doing with my data before I even start running models? Yeah, if I've got something that looks like this, one would hope that I would catch that in the bivariate plot, right? But when we start layering in multiple predictors, things can get kind of weird in multivariate space, and we might not see this, right? So Aiken and West go through, talk about procedures for looking at possible quadratic effects. And Ignacio, when you were asking about how do we go through and how do we determine whether or not we have a properly specified model or a misspecified model, like do I need interactions? Do I need sort of quadratic terms and things like that? There are techniques for working through and doing some of these types of things. Aiken and West go through and talk about some of that. Mostly, this is going to be a conceptual thing, and we think about, like, sort of based on the literature, what are the effects that I need to go through and make sure that I identify. But that's not always going to be the case. Okay. I was just working with Ryan on for his dissertation on, there was some weird stuff coming up in a model between a variable that's used pretty commonly in sort of the area that he's working in, right? And what it looks like is across a couple of different sets, it looks like this has we're getting pretty strong evidence of a curvilinear relation between X and an outcome in multivariate space that hadn't been previously detected. And if it was just one variable or one set that came up, that would be, maybe we pass that off, but it's coming up in a couple sections and the relation is looking very much the same. Now, there was a procedure, Ignacio, that we went through with these data, and it turns out that the nature of the transform is, oops. No, not that. Right? Is that a transform we're going to use or see sort of as something that's a normal go-to? No, right? But there are procedures for going through and identifying proper transforms for certain variables and things along those lines. But one of the things we just wanted primarily are doing with this is thinking about, if I'm finding an interaction and I have a situation where my predictor and my moderator are highly correlated, what I might start thinking about is, do I have it? Is there any possibility that this is a curvilinear function as opposed to an interaction? Questions on this? Okay, cool. All right. Let's go through, take another 5-minute break or so. When we come back, we'll jump into power, reliability, things along those lines. Okay, cool. All right, folks. We're getting close to being through this material. After this, we've got mediation stuff, and then we'll talk about probably some logistic regression things. So we're not doing too bad on time in terms of stuff. Any questions about moderation, sort of conceptually, anything that we've covered up to this point? No? Okay, cool. As you're working through this set, okay, use me as a resource. I'm here, I'm around. If you're having trouble sort of making things sum to zero, So obviously use each other, sort of talk with one another, sort of do all that. You guys are doing a really nice job through this. But just anticipate running into hiccups. Now, you can't obviously know what those are, otherwise you just wouldn't step on those landmines, but they're going to happen. So just make sure that you're giving yourself enough time. We still got lots of time to do this set, but just make sure that you're getting an early start on stuff. Okay, I'm going to post another screening video of me walking through full screening for a moderation set. That'll be helpful. And then I've also got an older screencast of walking through a different moderation example. If you want to watch that, that might be useful just to kind of get another example of what that might look like. So I'll go through and post both of those to make sure that you guys can go through and have a handle on stuff. Okay. All right. So what we're going to do now then is take a look and think about effect sizes, power, reliability, and some of these considerations that come up in terms of our moderation effects and regression just in general. So if we're going through, and we want to, again, and you guys know this because we've been working out about it for a full-on year now, if we're talking about effect sizes, this just corresponding to the magnitude of an effect within a population. You can also think about effect sizes as the extent to which the null hypothesis is false, right? Chris M., if we're thinking about means-based differences, if I have a D equal to 0.2, is that a small effect, a medium effect, or a large effect?
Generally considered a pretty small effect.
Pretty small effect, right? So you can think about that as D equal 0.2, the extent to which the null hypothesis is false, right? We're saying, well, these two groups aren't identical, but they're not all that different, sort of versus like a D of 1 or something along those lines, right? Now, the tricky thing with effect size, and I think part of the reason it hasn't caught on as it probably should in our science or across any number of sciences, is that our different analyses use different measures of effect size with different interpretations, and I think people sometimes feel overwhelmed with trying to keep track of everything. Okay, if we're talking about power, thinking about power is the long-term probability of rejecting the null hypotheses, right? So over an infinite number of replications, how many times am I going to, of a sample with an effect of this size, of a sample of this magnitude, how many times am I going to turn up finding the effect that's there, and how many times am I going to get a false negative where there's an effect in the population, I just didn't identify it, right? Again, our power determined primarily by our effect size, alpha level, sample size, the desired level of power, and what we're probably should be more concerned about in our field than we are is our underpowered analyses, which is going to give us our type 2 errors, the likelihood of failing to reject the null when the null is actually false. Okay. So this is all just a refresher because the issue is our moderation analyses are notoriously underpowered, hugely underpowered analyses. Our interaction effects in our social sciences are going to be generally small. Like, you should never read someone's power analysis and be, oh, I expected medium effects of this interaction. There's no basis for that unless there's strong evidence in the research that you can specifically point to. These interaction effects are very subtle, and our ability to detect these will start to become compounded by sort of issues with measurement error and poor reliability of our variables, right? If I start with poor reliability and then I add some more poor reliability to it and then multiply those things, I get something with really bad reliability. Okay, so because of all of these things, we should be, anytime we're thinking about conducting any type of moderation analyses, recognizing that our power to detect those effects is likely going to be very slim unless we've got really large samples and then also really good methods. Okay. So we're thinking about effect size in our multiple regression. Number of different effect size estimates that we can use to look at low order interactive effects. Again, going back to our handy dandy Venn diagram here, just so we're clear on notation, if I'm looking at r squared y given AB, right, we can think about this as the proportion of variability, total variability in y, attributable to the best linear combination of my set of predictors. Okay, so or thinking about this as notation for the r squared in your data. So you can think about this notation here as indicating, let's think about set A and set B. So set A is a number of predictors, set B is a number of additional predictors. In our moderation analyses, think about the set A as our lower order terms and B as our interactions. Okay, so for the data that we've been going through and using it as an example, think about set A as involving the direct effect of pain, PTSD, and opiate use, and then set B, the combination of PTSD and pain and opiate use and pain, those two interactions, right? And so what r squared y given AB is giving me the total variability in my outcome attributable to the best linear combination of all of my predictors, both set A and set B. So kind of thinking about this as like a hierarchical type of model. This is going to be different than r squared of y given A. Okay, this is going to be the proportion of variability in y attributable to the best linear combination of predictors just in set A, right? And so if my full model has predictors in set A and set B, r squared y given A, that's just the r squared for some reduced model, okay? And so if we're thinking about moderation, this could be the r squared if we're just including pain, PTSD, and opiate use, okay? So people kind of understand and sort of picking up the notation here. All right. What we can also do is take other r squared metrics and take some of the metrics that we associate with a single variable and extend those onto our sort of our total r squared value. So here, if I've got notation r squared y parentheses b given A, this is going to be the total proportion of total variability in my outcome that's unique to set B. Okay, and so if we're working with a hierarchical model, my r squared for y given parentheses b given A here, this is going to be equivalent to my r squared change. Okay, so if I'm say this is set A, this is pain, opiate use, and PTSD, that combination of predictors, and these are my interactions, right? R squared for y parentheses b given A, this is the proportion of total variability in y unique to B. So this is all the variability in y, right? What's uniquely being contributed by my set of predictors B is just this area here, right? So this value is going to be region C over ABCD, like the whole piece of things. Okay. Now, if set B is only one predictor, then this r squared y for b given A, this is equivalent to my squared semi-partial correlation for that variable, right? So if set A is just one variable and set B is just another variable, this coefficient here is just going to be C relative to all of this, and that's just my squared semi-partial correlation for that predictor. Okay, and so I can get this value by taking my r squared for my total set minus r squared with just the first set of variables. This is going to give me my unique contribution above and beyond here. Okay, people seeing how this plays out in terms of the math? I can also take a look and calculate r squared yb given A. This is going to be the proportion of residual variability in y that's unique to B, right? And if set B is just only one predictor, then r squared yb given A, this is like my partial correlation, okay? So here, if I'm looking at my partial correlation of B, this is just region C over D plus C, because what we're doing, A and B is accounted for by other stuff. We're pulling this out of the model and just looking at our residual variability here. Okay, I can get my partial R squared by taking my R squared for my total model, subtracting R squared for my reduced model, and taking that over 1 minus R squared of my reduced model. Okay, because if y squared given a, if this is my reduced model, if I take sort of y squared for ab for the full set, and I pull out stuff that's attributable to this, I'm just left with c in the numerator. And then 1 minus r squared ya is this, leaves me d and c. So I'm just left over with, you see, I'm going to try it. Let's see if this works. Okay, so this is going to be C over A plus B plus C plus D, right? People seeing that? Are people seeing what I'm seeing on my screen right now? Oh, I see. Okay, you guys are a screenshot. So I can't really see. Someone say yes, Josh. We see what you're doing.
Yes, Josh. We see
Okay, awesome. All right, I'm freestyling here. I don't know what is actually going on the screen here, but we'll make the best. All right, but with our residual or our partial coefficient here, this is just going to be region C plus D here. Okay,